Bismillahirrahmanirrahim. Last time we spoke about the curl of a vector field. And we said that the curl is given by nabla across the vector function f. And we finish with this remarking that if the curl of a vector field is equal to 0 everywhere, then the vector field is said to be irrotational. So if the vector field or if the curl is given by nabla cross f. And if this is equal to 0 everywhere, then we said that the vector field is irrotational. And if the dot product nabla dot f is equal to 0, we call that the fluid is incompressible, or it is solenoidal if we are speaking about the electromagnetic field. I've just typed application for this idea for the irrotational vector field. Let's have this example. Determine the values of the constants a, b, and c so that the following vector is irrotational. We are given a vector function v equal to x plus 2y plus az, px minus 3y minus z, and 4x plus 3y plus 2z. And we need to find the values of the constant a, b, and c, so it is irrotational. And irrotational means that the curl is equal to 0. So irrotational means that nabla cross f is equal to, as we defined before, as r sub y minus q sub z. Use this notation. This means this is b, not f. And p sub z minus r sub x, the partial derivative. And q sub x minus p sub y is equal to 0. Since it is irrotational, the curl is equal to 0. The first one is P, Q, and R. Let's find R sub y minus Q sub z and make it equal to 0. So it means that each one of these is equal to 0. 0, 0, 0, since it is irrotational. So R sub y minus Q sub z equal to, let's differentiate R with respect to y. This will give me C minus Q sub z, the second one is minus 1 equal to 0. We differentiate with respect to z, so all the others will be constant. This will give me C equal to 1. Now second one, P sub z minus R sub x equal to, let's differentiate B with respect to z. I will have A, this one. X plus y, when we differentiate with respect to z, I will have 0, so the remaining is only A. Minus R sub x, that is 4, equal to 0. This means that A equal to 4. Now third component, Q sub x minus B sub y is equal to, differentiate Q with respect to x, I will have B minus B with respect to y is equal to 2. And if it is equal to 0, it means that B is equal to 2. So these are the values of the constants A, B, and C, so that the given vector is irrotational. The curl of the vector will be 0. Just find the partial derivatives and equate them to equal to 0, or just r sub y minus q sub z, this component of the curve, make them equal to 0, and find the values of the constant a, b, and c. Now the second part of this topic, which is the vector field, was the divergence. Let's define the divergence of the vector field. The divergence of a vector field or a vector function f given by vi plus qj plus rk is scalar function given by divergence of f is equal to partial derivative of the first component with respect to x plus partial derivative of the second component with respect to y plus the partial derivative of the third component with respect to z. It's px plus qy plus r sub z. For example, let's find the divergence. Of the following. Number one, so that we have f equal to x squared minus 3y, x minus y plus 2z, and say y squared minus 3z to power 3. So that we are given this vector field, and we need to find the divergence. Divergence is a scalar function. It is not a vector. We have to be careful about this one. So the divergence of this vector field or vector function is equal to the derivative of the first one with respect to x is 2x. Differentiate the first one with respect to x. Second one with respect to y. Minus 1, because we differentiate with respect to y, it will be minus 1. And the third one with respect to z will be minus 9z squared. So it is just rearrange it. It is 2x minus 9z squared minus 1. This is the divergence of the given function. Take another one. So with that we have this vector function f x, y, z is equal to x y e to power x I minus x to power 3 yz j plus x y square k. And let's find the divergence of this function. Differentiate the first one with respect to x. With respect to x, I have to apply the product rule. Y is constant, multiplied by, it is x multiplied by e to power x. My function is x e to power x. So I have to apply the product rule, which is f prime g plus g prime f. So it is 1 multiplied by e to power x plus x e to power x. This is b sub x. Now I need to differentiate the second component with respect to y. It is q sub y. That will be minus y. If we differentiate, I will have 1, and x to power 3z will be constant, so it will be x to power 3z. Third one, with respect to z equal to 0. So this is the divergence. It is y multiplied by e to power x plus x, e to power x minus x to power 3z. So this is the idea of the divergence. Just find the partial derivatives of the components of the vector function. The first one with respect to x, the second one or second component with respect to y, third component will be with respect to z, and then find the sum of these partial derivatives. So I have this remark there, or one point here. Say that the curl of the gradient f, which is other remark. Number one, curl of the gradient f is equal to cross the gradient of f is equal to 0. Number two, the gradient of the function or of the scalar function is a vector. We discussed this before. The gradient of a scalar function or scalar field will give me a vector. So the curl of that vector will be 0. Curl of the gradient of the function is equal to 0. And also we have the divergence of the curl of f, which is lambda dot d cross f equal to 0. Let's have one example for this one. Let f be a vector given by 3x squared y I plus 2x z to power 3j plus y to power 4k. Show that the divergence curl equal to 0. So first of all, I need to find the curl, then I will find the divergence of the function. See? So let's find the curl of the function f. The curl given by sub y minus q sub z. This is the first component. Second one is b sub z minus r sub x plus q sub x minus b sub y. This will give me r sub y, which is this third one. Differentiate with respect to y, I will have 4y to power 3 minus q sub z will be 6x z squared. This is the first one. Plus p sub z 0 minus r sub x is 0. J plus q sub x is 2 z to power 3 minus p sub y is equal to 3x squared. Okay. Now this is the curve of the function. We differentiate the third one with respect to y minus the q sub z. Then b sub z minus r sub x for the second component. Third component is q sub x minus p sub y. Now let's find the divergence of this one. Divergence of the curve. It is the first one with respect to x. We differentiate the first component with respect to x. We'll have minus 6 z squared. It is b sub x. We'll say, we call it double b. Q sub y and double r sub z. I mean the component of the curve. So we differentiate the first one with respect to x. I got minus 6 z to power 2. Second one with respect to y is 0. Third one with respect to z, I will have 6 z to power 2. Now minus 6 z to power 2 plus 6 z to power 2, I will have 0. So that's it. This will prove the remark there. The divergence of the curve is equal to 0. We might have or take another example. Given f of x, y, z is equal to take x squared, y to power 3 and z to power 1. This is a scalar function. And we need to show that the curve of the gradient of the function f is equal to 0. Show that the curve of the gradient is equal to 0. So we need to find the gradient first. The gradient of the function is a vector. The gradient is given by f sub x, f sub y, f sub z. It is a vector. which is equal to, let's differentiate the first one with respect to x. We will have 2x y to power 3z. Second component with respect to y, it will be 3x square y square z, and third one with respect to z, it will be x square y to power 3. Now this is B, this is a Q, and this is R for the vector field. Now let's find the curl of this one. Is equal to, again, it is R sub y, the first, or the last one with respect to y minus second component with respect to z, I, plus b sub z minus r sub x, j, plus q sub x minus p sub y. Okay. Is equal to, first one, r with respect to y. We'll have 3 y square, or, okay, 3x square y square. Y square minus q sub z is 3 x square y square. This is the first one. Plus b sub z, this is the first one. It will be 2x y to power 3 minus r sub x, it is 2x y to power 3. This is j, second one. Plus q sub x, it is 6x y square z minus b sub y, that will be 6xy square zk. And it is very clear that all of these are 0. It is 0 vector. So the curl of the gradient of a scalar function is equal to 0. And also the divergence of the curl, and also the curl of the gradient, sorry. Curl of the gradient is equal to 0, and divergence of the curl of the function is equal to 0.